All right, this is out of section 6.1, I believe it is. Anyway, the area between these two curves. So first of all, I want to graph these two curves. So I'm going to take advantage of this line here. And this is x equal y squared as opposed to y equals x squared. So um, x equals 56 minus y squared. Now, if it was y equal 56 minus x squared, it'd be a parabola that's upside down, up 56. Well, this one is a parabola. This is positive x, upside down, so it's this way, going through plus 56. So out here at 56 is the vertex of the parabola, and it's going back this way. And now we have x plus y equals 0. So that means x equals negative or y equals negative x. So that's a line. The x and y coordinates equal to 0 there. Okay. So we got, yeah, that's what it looks like. Now I want to do this two ways. I want to do it with vertical slices and with horizontal slices so that you can see how they both work. So let's start with vertical slices. I'll do that one in red. Now, vertical slices over here are going to go between the curve, the top half of the parabola, and the bottom half of the parabola. But from here this way, the area between the curves go from the top half of this sideways parabola to the line. So I'm going to have to do this in two parts. In either case, the width of these things are in the x direction, so they're dx. Now, I kind of need to know where these intersect. So I'm going to take a moment and go to the side here and find out when these are equal. So y is equal to negative x, or x is equal to negative y. So I put negative y in for the x here. So I get negative y plus y squared equals 56. So if I subtract 56, I get y squared minus y minus 56 equals 0. Factoring this, I get y and 7 times 8, so 8 and 7. If I make the 8 negative and the 7 positive, I get negative 56, and I get 8y, negative 8y plus 7y is negative y and y squared. So that's how it factors. So y is equal to 8, or y is equal to negative 7. Well, this is where y equals 8, and x is the opposite of y, so x is negative 8. And this point is y is negative 7. And x is 7. Oops, sorry, got extra parenthesis in there. Okay, so now, maybe you couldn't see that. Let me slide that over for a moment so you can see what my arithmetic was on that. I put negative y in for the x, and then brought the 56 over and organized these in decreasing order, factored, and got those. Okay, so for these vertical slices, I'm going to integrate And since I'm doing dx's, I have to have everything in terms of x's. So the height here is y. Now, I need the total length in here, so I'm going to go to this curve. Well, the top half of this, if I solve for y in this, the top half of this curve, I would subtract the x. I would have y squared equals 56 minus x. I would take the square root, and the top half would be y equals the square root of 56 minus x. The bottom half of this parabola would be y equal negative the square root of 56 minus x. Because when I take the square root of both sides, I get plus or minus. This is the plus answer, and this is the minus answer. And you can graph this in your calculator, and it'll show you this. You can put a minus in front of this, and they'll put it down here. So I need to know I have the width of this, but I need to know the height, which is this height, the y value, this square root of 56 minus x minus this height minus, and that is the y value, which is negative x. Because this is the y value for this curve, and the y value is that. And this is the y value for this curve, and the y value for that curve is negative x. And I've got to integrate this. Now I'm doing it in terms of x dx. And I'm integrating x, so x would start here, which was negative 8, and go up to 7. That would figure out that area. Now for this area, I can do it a couple of ways, but I've got to add on, and this is going to be in terms of x again, because it's going to be dx, and I can integrate. The x is going to go from 7 to 56. And this height of this box, because I got to take the width times the height, just like I did here. This was the height, and this was the width. So the height of this is the top minus the bottom. Okay, so that's the integral I'd have to figure out to find the area between the two curves. Now, let's just type that into the calculator just as it is. So I'm going to go to, let's see, trying to put it someplace where you can see it and I can see what I got. Let's slide that over there, put that there, and I'm going to push math, integrate from negative 8 to 7. And my function is the square root of 56 minus x minus a minus, so plus x. I have an extra parenthesis in there. dx. And so it's telling me the area of this is 105, and I think that's 1/6. Now we need to figure out the area of this part. So math 9 from 7 to, I didn't finish. 7 to 56 of the square root of 56 minus x minus a minus, so plus the square root square root of 56 minus x dx. And that gives me 457 and 1/3. I don't know why it gave me 6 at the end, but it looks like 1/3. So if I add these two together, that's 1/6 and 2/6, 3/6, so it's a half. 550, 62, 562 and a half. Okay. Now, one thing I could have done differently, I could have just done the area of the top half of this. So it would have been the upper curve minus 0 and doubled it. But you can see that this and minus a minus made plus this, which would have been also just, that would have been two of these, and so I could have put the 2 out and just done this, which is what this is also doing. So I could have used the symmetry on this part. This part, I can't. Okay, now I said I was going to do it 2 ways. Now let's do it horizontally, which is, I think you'll find, a whole lot less messy. So I'm getting my blue pen. Now I'm going to slice it horizontally. So a slice would be something like that. Okay, to do this horizontally, let's see, maybe I can do it here. Come on, get that organized for you there so you can see it all. Come on, move. There. Okay. So now this direction is x direction of these curves. And the thickness of this is dy. And so I'm going to integrate, and it's going to be in terms of y. And y, I'm going to do these slices from here all the way up to here. And notice the highest part, the biggest, the most positive side, is this curve, this equation, or this equation, or this equation, and the lowest spot comes from this equation for all the slices all the way through. So I can just do it in one integral that starts, and since I'm doing dy, I got to look at the y's, and the y starts at -7 and works its way up to +8. -7 to +8. The top curve is this. It has x and y coordinates. I'm doing dy, so I want, in terms of y, This is the x length, and x is equal to 56 minus y squared. So that's how far it is from the y-axis up to here, and I got to subtract from it the height it is to this curve. So that's also x, and x is equal to negative y. So I got to take the height of the top curve, which is this, the x value of that curve, because the height is in the x direction, minus the x direction from the other curve, and the x direction of the other curve, the x direction is negative y, dy. So this one's a bit easier to do. So we have the integral. Well, I'm going to do the integration. 56 antiderivative is 56y. Antiderivative of y squared is negative y to the third over 3. And this is minus minus y, so that's plus y. And the antiderivative of that is y to the second over 2. And I evaluate from negative 7 to 8. And I'm going to do that. Now, since these are y's and not x's, it gets a little messy, but I could have typed this in just to show you how this works. If I go to math and number 9, and I could go from negative 7 to, keep forgetting to push the other button, to 8 over 56 minus, let me see if this will work, I believe it will, minus y, so I'm going to go actually type in the y, squared, plus y, and now I'm telling it my variable is y. So now the calculator is thinking that's why this dx is also important. This is saying y is the variable and there's y's in those places. And I press enter, and it gives me 560. Get this to show. Come on down here. 562.5. You can see the calculator. This is the answer I get, and it's the same thing as I had over here. And you can also see that it would be what I get from this. So let's go 56 times y, which is 8, times 8 minus 8 to the third divided by 3 plus 8 squared divided by 2, that's putting the 8 in, minus, and I've got a lot to put in here, so I got 56 times negative 7 times negative 7 minus parenthesis negative 7 to the third divided by 3 plus negative 7 squared. I better put the parentheses on there. Negative 7 squared divided by 2, and close that parenthesis there. So that's with the 7's in it. And if I've done this right, I should get the same 562.5. So I can integrate this. Now I could actually integrate that. I would do u sub for the 56 minus x, and I'd have a negative coming from it, and the integration of this becomes kind of challenging. Point of this problem: if it's stays the same between the two curves all the way through, it's a little easier to do the right minus the left, the right equation minus the left equation. And the slices would be dy, and I'd have to write all the equations in terms of y, x minus x, the large X minus the little x in it. If I do it slices this way, in this case, I'm working between these two curves for a while, and then I'm working between these two curves for another section, so I need to do it in two pieces. Okay, that's number 3.